Hello, my name is Sierra Bolton, and today is December 15th, 2023. So for case 1, we had a newborn baby girl that presented with apnea, hypothermia, and lethargy. Her lab results showed high blood ammonia that was rapidly rising, as well as high urine orotic acid. Her plasma citrulline levels were normal. So to go over ammonia transfer in the body, excess amino acids are brought to the liver where they are oxidatively deaminated. The ammonium produced is combined with carbon dioxide to form urea, which is filtered through the kidneys into the urine to be disposed of from the body. The non-toxic nitrogen carriers are alanine and glutamine. Transamination reactions help in this process because they transfer amino groups from amino acids to keto acids and vice versa. This creates new amino acids and new keto acids. Not only does this help in the removal of nitrogen from the body, this also helps to regulate amino acid and keto acid levels, as well as to produce energy for the body in the form of pyruvate. Aminotransferases include ALT and AST, and they require the cofactor peroxidyl phosphate. So in most tissues in the body, glutamate is combined with ammonia to form glutamine. Ammonia is generally in the form of the ammonium ion in our body. This reaction is catalyzed by glutamine synthase and requires ATP. In the liver, glutamine is oxidatively deaminated back into glutamate through the glutaminase enzyme. Glutamate is then oxidatively deaminated once more into alpha-ketoglutarate. This is through glutamate dehydrogenase and produces NADH or NADPH. The ammonium, as previously stated, is disposed of through the urea. In the muscles, glutamate and pyruvate undergo a transamination reaction to form alanine. This alanine then undergoes a transamination reaction with the alpha-ketoglutarate produced by the liver to form glutamate and pyruvate. Pyruvate is used as a source of carbon skeletons in gluconeogenesis during fasting. The glucose produced is sent back to the muscles. Some of the glucose produced is sent back to the muscles in what is known as the alanine glucose cycle. Carbon dioxide is combined with ammonia to form carbamyl phosphate through the carbamyl phosphate synthetase 1 enzyme. This carbamyl phosphate can either undergo pyrimidine synthesis, in which it forms the intermediate orotic acid, which can be expelled through the urine, or it can be combined with ornithine by ornithine transcarbamylase to form citrulline. The citrulline undergoes several reactions to form arginine in the urea cycle. I believe the most likely enzyme to be deficient in the urea cycle is ornithine transcarbamylase. This is because a deficiency in this enzyme would lead to an accumulation of carbamyl phosphate, which would lead to an increase in orotic acid being produced, which is what we saw in the patient. In this case, this might lead to a decrease in citrulline. That is not always the case. Sometimes with this deficiency, citrulline can be normal, It can be supplemented by the diet, for instance. However, if citrulline levels are decreased, this could lead to arginine becoming temporarily, conditionally essential. I believe the least likely enzyme to be affected is carbamyl phosphate synthetase 1. This is because if this enzyme were to be dysfunctional, we would have a decrease in carbamyl phosphate, which would lead to a decrease in urine orotic acid, which is the opposite of what our patient displayed. So for case number 3, a man was diagnosed with gout. His lab results showed an increase in plasma urate and a decrease in urinary uric acid. We're going to look at 3 possible causes for these symptoms. The first is purine overproduction. The second is a decrease in purine salvage. And the third is a decrease in the excretion of uric acid in urine. Looking at the first option, which is an overproduction of purines, I do not think that this is what the patient suffers from. Purine nucleotides are degraded into their respective bases, which are either deaminated or oxygenated to form xanthine. Xanthine is then oxygenated to form uric acid, which is expelled through the urine. If there were an overproduction of purines, this would lead to an increase in xanthine being produced, which would lead to an increase in uric acid in the urine. However, there was a decrease in urinary uric acid in the patient. If there were to be an increase in urinary uric acid, as expected if there were an overproduction of purines, then this would explain the increase in plasma urate, as uric acid dissolves into the blood to form urate ions, and an increase in urinary uric acid would cause an increase in plasma urate. The second option is a decrease in purine salvage. I also do not think that this is what the patient suffers from. Purine salvage is where purine bases are turned back into nucleotides instead of being degraded into uric acid, therefore decreasing the levels of uric acid produced and expelled in the urine. If there were a decrease in purine salvage, that would mean more purine bases would be degraded into uric acid, leading to an increase in urinary uric acid, which is the opposite of what our patient displayed. Once again, if there were an increase in urinary uric acid, as would be expected, and if there were a decrease in purine salvage, then this would explain the increase in plasma urate that the patient presents with. The third option is a decrease in the excretion of uric acid in the urine. I do believe that this is the case. I believe that the patient suffers from a decrease in excretion of uric acid in the urine, and a possible cause of this is excessive alcohol consumption. Alcohol and uric acid compete for excretion through the kidneys, which would explain why there might be a decrease of uric acid in the urine. This would explain a decrease in urinary uric acid as less uric acid is expelled, and this would also explain the increase in plasma urate, as the accumulation of uric acid in the body due to decreased excretion causes the uric acid to dissolve into the blood and form urate ions. The patient then informed us that he drinks 4 to 5 liters of soda a day. This means that he has a high fructose intake because soda is high in fructose. Fructose is metabolized into glycerol 3-phosphate, which can be used to produce ribose 5-phosphate in the pentose phosphate pathway. This ribose 5-phosphate can be used to produce the 5-carbon activated sugar PRPP, which is used to produce purine nucleotides, which, as discussed, are degraded into uric acid. Uric acid has a low solubility, so an increase in uric acid would cause urate crystals to form in the joints of the patient, causing pain and inflammation and exacerbating the symptoms of his gout. Therefore, his symptoms would be worsened by his intake of soda. Thank you.